So first, I will discuss about what is DevOps and why. What is the software evolution being observed in the previous years. So if you talk about software development over the years, so if you previously no there are everything to be manual. So if you go back to 15 to 20 years, everything seems to be manual. So where developers used to write the code and they used to go and build it, and so they used to deploy it, everything to be manual. So if you go by manual process, let's say if your application is very big, and if you're still using manual process, so then there is a lot of chances to human errors. And and also it will be very time effective. Let's say I'll take an example of Facebook. So if you see a Facebook, whenever you update if you update your status, so it will be available within seconds to all over the world. So how it is happening? Let's say let's go back to 15 years back, and just see how it will happen. So you will update that status in Facebook, and some developer needs to commit it and could develop and deploy it to manually. So it'll they have almost 100 servers or 1000 servers. It depends on their depends on their distribution. So let's say it two developers or three developers or 3 to 4 billion release engineer guys, or however the number, if they want to deploy the manually, it will take a lot of time, and you won't be able to see once you update your status. If they're doing manual process, you won't be able to see it of very soon. I mean, now if you update your status, how much it will take? It will take almost 1 minute, not even 1 minute. But if you follow that manual process, it might take half an hour, it might take 1 hour, it might take some time back also. So now what the software got evaluated like in such a way, within seconds, the fundamentals, the status whatever you're posting, it's been populating to the world within seconds. So how it is happening? It's happening through DevOps. So what is DevOps? It's all about automation using agile process. So if I talk about DevOps, so these are the main policies. So first we need to plan, integrate, build, testing, deliver, release. So all these scenarios you need to integrate in your DevOps. So in a nutshell, I'll tell you what is DevOps is. So DevOps is development plus operations. So when I say development plus operations, let's say if you have a project, so from the starting of the project, so from the first day of the project, so the all teams, like whoever involved in that particular project, like whoever gather the business, and business analyst people, project management people, development people, system admin team people, so operation team people like us, build and release team, and testing team people. So everything, support team people, everyone gather to a place and discuss about their plan. So this is what they call DevOps. But what happened previously is, it's all about waterfall method. I mean, there are some different models in software development. So previously what they used to do, everything used to be done in waterfall model. So what is a waterfall model? So when you take in waterfall model, it will be a step by step process. First you need to develop the code, and then testing, and then deploy, build, whatever, and then delivering it to client. So it takes a lot of time. So sometimes you might happen that if you take 2 months of time to write the code, and the customer came back and say, hey, I don't require that, my requirement got changed, or maybe you never know that even the project also got cancelled. So the efforts of 2 months and the effort of a lot of people is getting, it will be waste. So for that, to overcome those issues in waterfall model, so we came into a picture, agile development. So what is agile development? Agile development will happen in all your tasks, whatever the task involved in a project, it will be happen parallelly. So development will happen parallelly, and testing will happen parallelly, build and deployment will happen parallelly, software configuration or server configurations, each and everything will have parallelly. And they set up, they will call it a scrum. So every 2 weeks they split their work into 2 weeks. So every 2 weeks they discuss about their plans. The first, let's say this is the starting day. Usually it will happen on Mondays. So on Monday they'll all come together, and they discuss about the plan for what they're going to do in next 2 weeks. It might be a small change, or it might be a huge change. So those 2 weeks they'll work on that particular fix or particular change, and they deliver it to the client. So once they got approved from client, it will go to live. Or if they don't get the, if the client say, like, hey, I need some changes, so then we're not wasting much time. Only 2 weeks of time got changed. But we, if we talk about waterfall model, so almost 2 to 3 months of our time will be wasted. So in agile methodology, so you can have multiple changes frequently, and you can have the task parallelly. So development will happen parallelly. Development team will, testing their code, developing their code, and will just build their code and, deploying it. And the testing team supports those test cases. So everything will be happening parallelly. So the same agile methodology we have adapted for DevOps. So DevOps also, if anyone say that, hey, we are using DevOps methodology, so that should be agile. So that process should be agile. So DevOps uses agile process. So the operations, the development. So usually what happen in agile methodology is, it will mostly, the development will happen in agile methodology. So our team won't gather into that mode mostly. But if you say DevOps, so the development and operations both will be agile. So when I say agile, it will be, the task will be parallel. So in a nutshell, I'll just brief you again what is DevOps. So DevOps is it's not a kind of it's not a set of tools, or it's not a, it's not a platform. It's a strategy which is being we can get the strategy by using a development plus operations team together work on a particular project from the beginning day of the project. So it will be, in DevOps you can say the requirements will be changing frequently, and the development also will be agile. At the same time, operations also will be agile. Then only we can say it's a DevOps. So to do this, we need to have some set of tools, or we need to have some process, everything. So we'll see. So if you see here, what is DevOps? So DevOps is a software development approach which involves continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring of the software throughout its development lifecycle. What is meant by this continuous development? So developers will write their code continuously. They keep on do their changes to the code, particular code. And continuous testing. What is meant by continuous testing? So the moment they do any changes to the particular code, it should be tested. So what if this continuous testing or continuous integration is not in place? So what will happen is, so let's say 2 weeks we are following agile, and we do changes 2 weeks wise, right? So for 2 weeks, so they write a lot of code, they do a lot of changes. If they didn't, tested the particular code on the particular time, so after going back to that particular deployment time, so they may never know that which, if they got errors also, they might never know that which place they are getting error. So if they are having continuous development, so on the, let's say I'm a developer, and I've just written some few lines of code, and I just tested it. It went fine, and few more hours, I'll write some more code, and I'll test it, and it got failed. So I can easily know where the build failed, where the code failed, where the error comes from, because the first 10 lines which I've written is success. The second 10 lines which I've written got, when I club mix both, I got error. So maybe some dependencies issue, some maybe but I can easily understand the issue, where the issue come from. So that's why we need to have continuous testing and continuous integration is a must in place. So what is continuous integration, what is continuous deployment? We'll talk about this in future. So if you see here, you need to plan, code, build, test, and you need to integrate, and then deploy, operate, monitor. So what is meant by continuous monitoring? So your application, your server should be monitored 24/7. It should be up and running always, and you need to have some monitoring tools, so to achieve that continuous monitoring. So we'll take a look at what are these tools we'll use. So to plan and code will be required some we'll say version control tool. There are a lot of version control tools available in the market, like CVS, SVN, Git, ClearCase. They're all, but now the market is occupied with Git. Git and svn. So we'll cover about Git. And if you talk about build, so what is build tool so okay, what is version control tool? So version control tool is to store your data or code and to change, to track those changes. So whatever changes you made it to the to a particular version control tool, you can change it, you can track it. So we'll talk about in detail when we go to that uh, particular topic. So build, so one you have ready you have your code ready in version control tool, and so those code will be in different files like xml formats, and it's not an executable file. So what the build do is, the build tools are what will take care of, it will compile your code, it will test your test cases and package your application into a executable format, like in Windows .exe, .msi, and if you talk about Linux, it will be jar var files. So it will compile the code and in package that particular we can say, we call it artifacts. So how it will do, and we'll go into we'll talk about when we go into topic. So there are build tools such as Maven and Gradle. So there are different tools, and here comes the test part. So testing part will be mostly taken care by testing team, but if sometimes we might need, but now as of now it's not required. But there are some tools which JUnit and Selenium, it's for automation of testing. And if we talk about uh, monitoring, they have Nagios, Sensu, New Relay, different servers, and they have, if you see here, there are different of configuration management servers. So what do you mean by configuration management? So I'll ask you to you have two people in your project, and you have almost 1,000 servers. So I've asked you to install Java on those particular 100 servers. How much time it will take? Let's say an hour or 1.5 day, or maybe depends on how fast you work on that, and you're doing manually. So 100 servers, and there is a chance to mismatch the versions in those 100 servers. So you might some developer A might install Java 1.7, and developer B might install 1.8. So there is a mismatch, and we cannot, if sometimes we need to give admin access or root access to project managers or team leads, and we never know that what the changes they have done in the server until unless we went there and checked that. So, and let's say there are two people working, so one guy is on leave and he installs something, so there is a new guy came, and if you want to understand the process or understand the install files where he is installing, it will be very hard for him. So then there is a concept came, configuration management. So what is configuration management? It's just infrastructure as a code. Whatever you have your infrastructure, I'll write in a single file, I'll write in code, maybe it Ruby, Python, whatever. It depends on the tool which we are going to take. So I'll write it in a simple file, and I'll just execute that particular file into the 100 servers. So if I want to install Java on those particular 100 servers, I'll just write a file and I'll just push that file to the servers. It will be 5 minutes of task, and all the 100 servers will be having same version. And in future also, if I want to update the Java, I need to log into the servers. I just go to that particular file and I'll just change the Java path or Java version and just deploy it. And let's say if a new person also came, so it will be very easy for him to understand the process. So you just look into that file, that infrastructure as a code file, and you can easily able to understand what are the softwares being installed, which place he is installing, and which path, which version. So everything is able to understand. It will be very easy for him. And the most important feature is, if anybody wants to do any changes to a server, so even though they do the changes, it won't apply to the particular server. So first we'll get a notification and we can review those changes. So once we approve those changes, then only those changes whatever done by the others will be applicable to the particular server. So the control and configuration, everything will be in our hands. So it will be very secure and very easy to understand the process also. So we have almost there are different servers, configuration management tools such as Puppet, Chef, Ansible, Salt. So Chef will be, you need to have a good understanding of Ruby. And if you talk about Puppet, mostly system admin team will use that Puppet, and for that also you need to have little very basic understanding of Puppet. And Ansible, compared to Chef and Puppet, Ansible is little easier, but now the market is more occupied with the Puppet, so we'll talk about Puppet. And see, now we talk about all these tools, and we have a containers tools like Docker, and we have cloud technologies like AWS. So why we need a cloud? So let's say, if you have a if we are working in a project, and that project has almost 10,000 of servers. So those 10,000 servers, they need to have a backup setup as well, though that they call as a DR, disaster recovery. So to manage those 20 plus thousand servers individually, so one is operating normally and one will act as a backup. So both should have operating, and they need to have some. So to maintain those servers, you need to have a data center. So, and the data center is cost involved. So and you need to maintain two data centers. So one in some place and another one is some place. So both need to have a power 24/7 backup, power backup, internet, AC, resources, everything will be there. So that you should be up and running both data centers always, 24/7. Not even a single minute you cannot shut down that data center. So, and also, if you want you need a one Red Hat Linux machine, or Windows machine. So you ordered one, and one after working for 2 years that particular project, the project got over. It got so what will do? You'll just decommission that particular box. And what happened after that? So you cannot use that. If you want to if any project wants that server, you can just use that server. Or if mostly it will be every server will be occupied with the project, every project will be occupied. So the servers will be useless. It will be just staying idle there. So, and you paid full amount lifetime. You already paid whenever whenever you're buying that particular server, you have to pay full. So, and you just use it for 2 years. So, and after that it will be idle. If you want to, even if you want to sell for others also, it will be the no, or you know, right? And if you want to sell any second hand item, the price will be got down. So to overcome all those issues, and even if you want to have a Red Hat Linux mission, if you need to send an email or a purchase from a Red Hat server, and they'll take almost 1 week to deliver you a mission. Not even 1 week, just 2 or 3 days at least. And after that you need to configure, and it will take, to make a readily available server, it will take at least a working day, 5 working days. So then cloud came up with a concept like, uh, you don't worry about your data centers, you don't worry about your resources, everything will take care. You just pay for what you use. So mostly AWS we are using. So AWS main concept is pay for what you use, and they will give you resources, or they will give you instance servers, Linux machines or Windows machines, in 2 minutes. And let's say I've spin up a VM. I've got from Linux one Red Hat VM, and I've used for 2 months. After 2 months, if I think that I don't need that, I can just stop it. I can just terminate it, and I no need to pay for others. Pay for other time. I only can pay for only that 2 months whatever I've used. So to to get a VM, or to to destroy it, or to maintain it, and you need to maintain about those data centers also. Even though it is cost involved, they will take care about it, and all those resources, everything. So the Linux you can just pay for what you use. Whenever you feel like you don't need their services, you can just stop there, and you don't need to pay for full. You just for if you use for 50 days, you will pay for only 15 days. If you use for 35 days, you can pay for 35 days only. So that's what they call it. I mean, pay for what you use. And usually, what is cloud? So you can access this particular application over internet. So cloud means access your application over internet. So that will talk about AWS. There are a lot of different cloud operations as well, like Microsoft Azure and Google Cloud and IBM Bluemix. So mostly 70% of market is occupied with AWS. Okay, so we talk about almost a lot of tools. So but we need to have a center, a kind of bridge kind of a tool which will talk to the all those tools and communicate, and it will make it sync. So for that we have a tool called Jenkins. We can call it as a continuous integration tool, and some people call it as an automation tool. So what does it do? We can integrate various different tools whatever we are using in our project. And let's say we have there is a requirement. So whenever there is a change to happen to a particular repository in version control tool such as git, so that should, the particular change, the particular code should be built, tested, built, and deployed into the application servers. So how will that happen? It will be taken care by Jenkins. So first it will communicate with Git and check for that particular in a repository any changes is happened, and then it, if there is any change, then it will communicate with the build tool, and it will build that code, and then it go to so once the build is happened, it will go to the application servers, it will talk to the application servers and deploy it and send us a email notification that this build failed, that build success, like. So so the integration we need to do it, and once we have integration everything, so it will be easy to track, or easy to it will be all automated, all automation, you can say. So previously what happened is, once the developer do the changes, he manually go triggers the build and test it and see it. But now it's not, you don't need to trigger any build manually. He just push his changes to get repository or subversion. The Jenkins will take care about it, building and testing and everything. So this is all about DevOps and the tools being used. Then I'll cover about the excuse me, course content. So we need all most of the servers, most of the companies are working in using Linux platform. So we'll talk about Linux. We'll discuss about the commands which we're not going to talk about in detail Linux administration, but we'll talk about basic commands what are required to to perform a DevOps role, and we'll talk about shell scripting as well, and then we'll have an introduction to DevOps. So what we'll do, an introduction to cloud computing. What is cloud computing? What are the services and everything? And then we'll talk about Git. So what is Git? Uh, uh, what are the previous version control tools? And we'll install Git on Linux and Windows and setup. So and then we'll create a repository, and the basic some commands will be there, and we'll see it. And then we'll go to AWS, and there are a lot. If you go talk about AWS, there are n number of servers, almost 478, or 500 plus, almost 500 plus servers services. But for DevOps role, we need to know about 10 to 15 services only in AWS. So we'll talk about those 10 to 15 services, and we'll see how it will install, and we'll talk about Puppet. So how we can install Puppet, how we configure master and agent, how we'll see, and we'll see this, and we'll talk about Jenkins continuous integration tool. So we'll install Jenkins, we'll create some jobs in Jenkins, and we'll see this. And then it comes Docker comes it in picture. So Docker, will see what is Docker, what is difference between Docker and normal VM, and how Docker is performing, how to create an image, how Docker works, and all those we can see. And then we'll talk about Vagrant. I'll tell you what is Vagrant is. So and we can do some changes. The course. There is no need to follow this particular structure. First we can start with Linux, and then we can go ahead to Vagrant, and then we can go to Git, and then we can go to Maven. Actually Maven is missing here, so we'll be talking about Maven as well. Let's see, I'll include this. And okay, this is all about course content and so